Hey guys, hope you're all well, looking after yourselves, looking after each other. What we're going to be doing today is we're going to be looking at what happens to the resistance of resistors when we add them in series and when we combine them in parallel. You're going to do some problems on them, and I'm going to demonstrate to you now what happens to the resistance with three resistors. Okay, what you need to do for IGCSE is you need to be able to explain what happens to the resistance when they are connected in parallel, but you don't necessarily need to do calculations. You're going to do some calculations though already. And the other thing you do need to know is how resistors are, or what happens to the value of the resistance when they're combined in series. There's a little bit of maths, but it's really straightforward. Okay, so first off, we've got some resistors here. I've got three resistors to show the principle. These resistors here are 220 ohm resistors. I can tell that by the color combination on the inside of the resistor here. When it comes into focus, there we go. So you don't need to know the color combinations, but that's how I can read what the resistance is. I've got my multimeter here, my favorite thing in the world, and I've got it set to read resistance. So I'm going to just check the values of each of these resistors and I'll make a note of them. Okay, so first resistance here for this one, whoops, is 220.1 ohms. So I'll say 220 ohms. So I would say 220 ohms there. And this one, this is exciting, I can tell you, 221 ohms. Resistors are never made exactly to the specification. They have something called a tolerance because it would be ridiculous for companies to produce an exact 220 ohm resistor because you never need precisely 220 ohms. And this one's 221 ohms. So we've got 221 ohms here. What I'm going to do is join them together in series. And so I'll just connect two together in series. So I've got the 221 ohm, the two 221 ohm resistors, and let's see what the resistance is. Let's see what the resistance is when the voltmeter turns itself on. 442 ohms. So we can see here that resistor 1 and resistor 2, their total resistance when added together is just the value of R1 plus R2. So 221 plus 221 equals 221 plus 221 equals 442 ohms. And that was the total resistance of both of them. Now let's just check that this works again. So resistor 1 had 220 ohms, resistor 2 had 221 ohms, this one had 220 ohms. So our resistance should be all three of those added together. Let's just double check. So it should be around 660 something. Yeah, 663. Oh, perfect. So 663 is probably a little bit higher because this was probably 221 and there's a little precision error there. So in this case, the total resistance, if this was R3, the total resistance is just R1 plus R2 plus R3. So 221 plus 221 plus 220 equals 662 ohms. And that's all you have to do to work out the total resistance of a resistor, or resistors when they're in parallel. But let's watch what happens now when we combine resistors in parallel with each other. So I've got my two resistors here. I'll do it first with two resistors. And I've got my two resistors here. Just clean this off. You can hear that rattling. It's because I'm using a mug to weigh down this tripod that I'm using. So it's the mug's rattling. Right, okay, so I've got my two resistors here. Both of them were around 220 ohms. Yeah. Let's join them together, and we've joined them together in parallel. Now the circuit diagram for this will look something like this. Yeah, and we'll call this R1 and this R2. So that's what the circuit diagram looks like, and you can see it's pretty straightforward how we've done that. Okay, so we're going to see what happens to the total resistance of these two resistors. They were 220 ohms before, both of them. They're in parallel now, and 110 ohms. So the resistance has gone down to 110 ohms. So the reason because of this is, the formula to work out the total resistance is actually 1 over the total resistance equals 1 over whatever R1 was plus 1 over whatever R2 was. Now in this case, just move my camera so you can see a little bit better. So in this case, 1 over the total resistance is going to equal 1 over 220 plus 1 over 220 ohms. Now that's a nice fraction, so let's simplify that fraction a little bit. Okay, so 1 over 220 plus 1 over 220 equals 2 over 220. Now that's not the total resistance, but what we will do is we have to flip the equation. So we will now flip the equation, so RT over 1 equals 220 over 2. RT divided by 1 goes away, so that means the total resistance, the new total resistance is 220 divided by 2, which is 110 ohms. Okay, now you will not be expected to do this calculation. However, in an exam. However, I think it's important that you actually have a go and try and do these calculations. So I'm going to give you on a worksheet that I've attached some calculations to have a crack at, okay, based on this. But let's look at what happens before we do that. Let's have a look at what happens when we add a third resistor. So what you need to be able to describe is what happens as you add more resistors in parallel. So let's just join this together in parallel, and I'm doing a terrible job here, mangling my resistors all together, but now they are all linked in parallel. There's 3 of them now. So when we had 1 to start off with, when we had 2 to start off with, it went down to from 220 ohms to 110 ohms. Now we've got 3 in the mix, so R1, R2, and R3. And let's see what happens to the resistance. Let's see what happens to the resistance when Mr. Wrigley can hold this properly. Here we go. 74 ohms. So the total resistance was 74 ohms, and here's why. Okay, 1 over the total resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so in this case, 1 over RT equals 1 over 220 plus 1 over 220 plus 1 over 220, which will equal 3 over 220, just like before when we were adding them up. So now it's 1 over RT equals that, and then we flip the triangle again. So in this case it was 1 over RT, we flip it, so RT over 1, which cancels out, equals 220 divided by 3. Now, I'm going to be a lazy physicist, and 220 divided by 3 is about equal to 70-something ohms, okay? Which is why you can do the count. I just don't have a calculator with me right now, and I'm being very lazy. It was very bad of me, but it'll equal around about 73 point something, and that's how it works, okay? So, hopefully that was useful to you. I have a go at the worksheet, and I'm also going to send you links to a simulation where you can actually test this out for yourself if you're not as nerdy as me and don't have a load of resistors and multimeters lying around. Okay, take care guys.